Hi, Claire here, and we're looking at index laws again. So this time I'm going to look at raising a power to a power. It's index law 3. So if you look at 2 cubed, which has been raised to the power of 2, you can solve this by first principles by writing 2 to the power of 3 multiplied by 2 to the power of 3. In effect, it's been squared. And because the bases are the same, you can add the powers, which will be 2 to the power of 6. But if you look at this another way, you can see that 2 times 3 also equals 6. So we can actually simplify this rule to a to the power of m, all raised to the power of n, will be equal to a multiplied, at least a raised to the power of m multiplied by m. Okay, so that's the rule, and now it can make our work much easier. So x raised to the power of 4 raised again to the power of 5 simply means you multiply those powers. So 4 times 5 is 20. Much easier, isn't it? So now we have to look at the tricky decisions we need to make with regard to brackets. So here we have a 3 on the outside of the brackets. So that will be 3 multiplied by something. We have y raised to the power of 5 and then squared. 2 times 5 equals 10, which can be simply written as 3y to the power 10. Now, if the 3 was inside the brackets, it would also need to be squared. So that would be 3 squared multiplied by y raised to the power of 2 times 5, which is 10. So that would be equal to 9y to the power of 10. Okay, so you do need to really watch what is actually being raised to the power, and the brackets will help you realise whether or not you need to square it or raise that whole number to a power. Let's look at the 0 power. It's a really important rule, and I'd like to demonstrate it to you in 2 ways. So we have 2 raised to the power of 5 divided by 2 raised to the power of 5. So if we write this as a fraction, you can see that the same quantity has been divided by the same quantity. Or you can think they are both common factors. So 2 to the power of 5 goes into itself once. 2 to the power of 5 goes into itself once. 1 divided by 1 is 1. Let's look at this one. Let's use the second index law to solve this one. So we have the same bases. They're both raised to the power of 5. So we can subtract the powers when the bases are the same, and it's a divided problem. So this will be 2 raised to the power of 5 minus 5, which equals 2 raised to the power of 0. So the questions were the same, the answers are different, so the answers must be equal. Any number raised to the power of 0 equals 1. This can be demonstrated in another way, and it's a really important identity to know. So this has got lots of valuable maths facts in it. You can see I've started with 10 to the power of 4, which is expanded as 4 tens multiplied by itself, and then the answer is 1 with 4 zeros. Pretty straightforward, 10,000. So 10 cubed is 10 multiplied by itself 3 times, which equals 10 with 3 zeros. 10 squared, I think we all know, is 10 times 10, which is 100. 10 raised to the power of 1 is simply 10. And so look at 10 to the power 0. If you look at the pattern, as we're going up the pyramid, a 0 has been removed each time. 4, 3, 2, 1, and now the last 0 is removed. So 10 raised to the power of 0 equals 1. Let's look at how some of these problems play out. Using brackets. Negative 3 raised to the power of 0. Looks hard, but it's not. It's raised to the power of 0, so it equals 1. If the negative is on the outside of the brackets, it means negative 1 has been multiplied by the solution to this. 5x raised to the power of 0 is 1. So that simply equals negative 1. Let's look at this one. You have 2 multiplied by y to the power of 0. this equals 2 multiplied by y to the power of 0 is 1. 2 times 1 is 2. Little numbers, but they can be tricky. So we've already solved this. 2 minus. So you have 3y, all in brackets, raised to the power of 0, which equals 1. 2 minus 1 is 1. Okay, some trickier problems. So, not too hard. Raising a power to a power. X squared raised to the power again of 3 is going to be x to the power of 2 times 3, which is 6, multiplied by x raised to the power of 3 raised again to the power of 5. 3 times 5 is 15. So now you have the same base and raised to different powers, so you can simply add them. 15 plus 6 is 21. Problem solved. Let's look at the next one. So working on the top line here, m raised to the power of 3, again raised to the power of 4. 3 times 4 is 12. Divided by m to the power of 7. So we subtract these powers. It'll be 12 minus 7. So 12 minus 7 is 5, and it remains on the top line, upstairs. Okay, so let's have a look at these, which might require some expanding. So remember, they're all multiplied on the top line. So let's just do the top line first. So it's 4 times x squared times 3 times x cubed. And it's all over 6x to the power of 5. Right, 3 times 4 is 12. Add the powers. 2 plus 3 is 5. Divided by 6x to the power of 5. Okay, so you can see we're in that situation now where we have 6 is a factor of both 12 and 6. And also you have the same x to the power of 5 on the top line and the bottom line, in the numerator and the denominator. So 6's go twice into 12, once into 6, and these cancel to 1. So the answer to this whole big problem was simply 2. I gave you a worksheet yesterday, and I had some people ask me some problems from that worksheet. They were the mixed operation ones, so let's have a quick look at them. So we have a division here and a multiplication. So you can write this as a fraction. You can write this as 6n to the power of 8 divided by 12n squared. And on the top line, you will need to multiply that by 4n to the power of 12. Looks a little messy, but this is the way it is. Doing the top line. So you have 4 times 6 is 24. And you add the powers, they're all n's, just check they're the same base, and you can add them. That will be n to the power of 20 divided by 12, n to the power of 2. Okay, so we can now finish this off. 12 is a factor of both 24 and 12, once, twice. And now it both have the base n, so you can subtract the powers. So it'll be 2n. 20 minus 2 is 18. This one here is a fraction law. D to the power of 7 over 2 divided by 3 over d to the power of 4, or multiplied by its reciprocal, or its inverse, or flip it. So it'll be d to the power of 4 over 3. Thought you were going to be able to cancel, but no deal. So on the top line, you will be, the numbers have the same base, the indices have the same base, add the powers 11, and 2 times 3 is 6. End of that one. This was another one, a little bit tricky. So you have 5 to the power of x over 5 to the power of 1. So let's put the 1 in there. The bases are the same, so you subtract the powers. So it'll be 5 to the power of x minus 1. Okay. Thanks for your attention, and I hope you can try the worksheet on OneNote. Bye for now.